In this video, we'll be comparing the characteristics of a single acting cylinder, so using the three two-way valve, so versus double acting cylinder using five two-way solenoid valve with single coil, and double acting cylinder with or using five two-way valve but with double coil. Okay, so first is we need to have the cylinders. Okay, so we have the single acting cylinder. Okay, so this must be paired with, okay, so this will be paired with uh, the three two-way solenoid operated valve. Okay, so this one. Okay, so in between the um, cylinder and the solenoid, so we need to have the, okay, so uh, airflow control. Okay, so that is given by the shut off valves, no? So we use the one way flow control valve. Okay, so you just need to rotate this one. Okay, so using this button, so we can use this one to connect. Okay, so in between the cylinder and the solenoid valve, so the purpose of which is to adjust the flow of air coming from the solenoid valve to the cylinder. Okay, so we can connect it there like this one. Okay, so and of course the source. So perhaps we can change this to 10% opening. Okay, so we can have it 10%. Okay, so we can display the opening level and then click OK. And then for the, okay, so for the double acting cylinder, okay, so we have the double acting cylinder, and then this must be paired first with the, okay, the 5 two-way, no? So 5 two-way solenoid valve, single solenoid, this one. Okay, so just drag it there. Okay, so then, okay, so if you try to look at the two solenoid valves, they look like uh, the same, but they differ, no? So with respect to the number of ports. So for the 5 two-way, so we have their 5 ports, 3 two-way, so you have their 3 ports. Okay, so we just you can just copy paste the shut off valves, this one. Okay, and then have it, so copy this one and paste, so we can connect, no? So two shut off, no? So valves, so to the double acting cylinder. One is to control the airflow, so used to extend the cylinder, and then the other one is used to control the airflow or the speed, or to regulate the speed of the air used to retract, okay, so the cylinder. So we connect so the following service ports. Okay, and we need to have the source of air. Okay, so the compressed air supply. Okay, so for the compressed air supply, we can have it common to each of the cylinder. Okay, so we can have it common to the cylinders, no? So you notice that for the 5 two-way solenoid valves, there are two exhaust ports, the port 5 and port 3. So this is where the air will flow. Okay, so when it is removed from the double acting cylinder. Okay, so now we try to simulate, as you can see. So take a look at the operation of the the single acting cylinder using the three-way solenoid valve. So using the manual button, okay, as you can see. So by pressing the manual button, that means you are energizing the coil. Okay, so when you energize the coil, so the cylinder extends, but when you uh, de-energize, that means you release the manual button, so the cylinder will retract. Okay, so on the other hand, the double acting cylinder, okay, so this one, so if we try to energize this coil, so the cylinder, okay, so if you try to hold your mouse, okay, so the cylinder extends, but then if you try to release, okay, the manual button, the cylinder retracts. Okay, so as you can see, both of the cylinders, okay, so the single acting cylinder and then the double acting cylinder using the single solenoid coil delivers the same output. Okay, so for the single acting cylinder using a three-way valve, you energize the coil, the cylinder extends, you de-energize the coil, the cylinder retracts. Okay, so for the double acting cylinder, you energize the coil, the cylinder extends. When you de-energize the coil, the cylinder retracts. Okay, so how do the two pneumatic system differs? So in the single acting cylinder, okay, so if you can see, there is only one way we can control the speed, okay, so of the um, cylinder. Okay, so that means if we try to increase, so just make it, uh, let's say, 50, okay, and then, okay, so as you can see, so you have there the movement, no? So the movement of the um piston rod. So if we try to increase the opening, so the movement of the piston rod, either in the retraction or the extension, increases also. But for the double acting cylinder, so one of the advantage that if you can adjust the speed, okay, so of the cylinder either in uh, extension or in the retraction. Now, for example, we increase the speed during the extension process. So, for example, we change this one to 50. Okay, so whereas the retraction remains 10%, okay, as you can see, okay, so as you can see, the uh, okay, so the speed, no, so of the double acting cylinder, okay, so it actually changes, no, so let's say this would be 5, okay, okay, so uh, in the double acting cylinder, so you can adjust, no, so you can adjust both the speed of the extension and the retraction process. Okay, so unlike with the single acting cylinder that uh, the extension and retraction process, no, so as you can see, if we change this one to let's say 5, okay, okay, so the speed of the extension and the speed of the retraction will be the same. Okay, so almost the same. But if we try to take a look at the double acting cylinder, so we change this one to, for example, 80% opening. So you want the extension process to be faster, whereas the retraction process to be slower. Okay, as you can see, so the speed of the extension is faster, but the speed of the uh, retraction, that's actually slower. So that is where the advantage, no, so of the double acting cylinder comes in as compared to the single acting cylinder. But when uh, compared as to functionality, so both of them will have uh, the same function. So they only differ as to the principle of operation. That means if you have single acting cylinder and then with a three two-way solenoid valve, it can be replaced. No? So the operation can be replaced by a double acting cylinder using five two-way solenoid valve but with single coil. Okay. So how about the cylinder? No. So with uh, a double acting cylinder with uh, two coil, five two-way solenoid valve. Okay. So we try to simulate. Okay. So in order for us to evaluate, no. So how does the five two-way solenoid valve double coil works? Okay. So we copy this one. Okay. So we just you just can press Control C and Control V. Okay. So and then for the double acting cylinder, okay, so the double acting cylinder, five two-way, no? So five two-way double coil, okay. So you use this one, five two-way solenoid impulse valve, okay. So you can see there are two, okay. So there are two coils now, okay. So we connect the shut-off valves, then connect the okay, connect the other end to the solenoid valve and then the source, okay, so will be connected to the compressor. Okay, so we try to simulate. Okay, now using the double coil 5 two-way solenoid valve. Okay, so you extend, no, so you extend the double acting cylinder by activating the first coil. If you notice, uh, okay, if you notice, uh, even if we release, no, the um, manual button here, okay, so the cylinder, okay, so by pressing it or by pressing the manual button here, so the cylinder extends, but if we release, so the cylinder remains in the extended position. So unlike with the single coil that when you press the manual button, okay, and then release, so the cylinder, no, so the cylinder uh, returns immediately to the extended, I mean retracted position. For the double coil, so the cylinder remains, no, in the extended position to allow, no, so to make this case cylinder return to its um, retracted position, so we can activate, no, so the other coil, okay, so this one, So activating this one, so that will enable the cylinder, no, so to retract. Okay. So the purpose of the solenoid coils for the double coil 5-way valve is that the first coil is used for the extension process, whereas the second coil is used for the retraction process. For single solenoid, I mean single coil, so you just energize the first coil, okay, this one, and then you want the cylinder to retract, so you just de-energized or turn off, no, so the supply uh, in the uh, coil, no, so of the solenoid valve like that. Okay, and then uh, the cylinder, no, so will retract. Okay, so okay, so that's the difference, no, so between the 5-way, okay, so double coil and single coil solenoid valves. Okay, so the single coil solenoid valve may replace, no, so the setup of single acting cylinder using the 3-2-way solenoid valve. So meaning to say, if the double acting cylinder is not present, and then the 5-2-way single coil is also not present, so this system here can be replaced by this one because it does have the same function. Okay, so only that the speed, no, so you can just alter one speed only, no, for the double, I mean the single acting cylinder. So but then the functionality as to when can the cylinder extend and when can the cylinder retract, so that is the same as with the double acting cylinder using 5-way single solenoid valve. Okay, so now we'll try to explore the control mechanism, no, so of the uh, electropneumatic system. Okay, so this time we'll be using the okay, so the okay, so this time we'll try to have the other type, no, so of ladder uh, circuit, so which is the European, no, so European uh, standard. Okay, so okay, so for the European standard, so the power supply, no, so or the ladder circuit will be arranged from left to right. Okay, so that means we start with the positive supply. Okay, then the negative supply will be placed, no, so at the okay below, no, so the positive terminal. Okay, so let us say we want to control, no, so the single acting cylinder. Okay, so the coil, no, so the solenoid. Okay, so the solenoid valve. Okay, so we need to name the following solenoid valves. Okay, so that would be we name this one YA, this one to be YB, and then this would be okay, so this would be YC. Okay, or perhaps you can have it Y1 instead of YA, and then this would be Y2, no? So instead of YB, Y3 instead of YC, and lastly, you have their Y4. Okay, so because the other, okay, so the other double acting cylinder is using two solenoids, no? So that's why you have their Y3 and Y4. Okay. So first is we want to control, no? So the extension process of uh, the single acting, no, cylinder using the the European standard. So we first, okay, so need to have the solenoid, okay. So for the solenoid, so it's under relays. So this one, so kindly click valve solenoid. Okay, so put it there, and then in order for this to extend, okay, so this solenoid will be connected to the power source, just like this one, no? Okay, so just double click and label it Y1. Okay, so once you start, no, dissemination, so automatically the single acting cylinder uh, extend, no? So also if we want the double acting cylinder to extend, okay, so we'll just make this one as Y2. Okay, then simulate, so automatically the double acting cylinder extends, right? Okay, so in practical applications, okay, so it is customary, no, so to have uh, a push button, no, so used to control the uh, solenoid valves. Okay, so we try to delete this one and have the push button, normally open push button. So under manually operated, you can have the push button, this one. Okay, so normally open push buttons will be connected in series. Okay, so with the solenoid valve. Okay, so you can double click this one and then uh, label it PB1. Okay, so or basically NOPB1, NOPB, normally open push button. So you can drag the label a bit further, no? And then simulate. So you okay. So you push the push button here. Okay. So the cylinder extends. You release the push button, the cylinder retract. So if we make this one as Y1, okay, and then simulate. So the same output, no? So you press the button, the cylinder extends, you release the button, the cylinder retracts. Okay. So meaning to say the operation of these two setup, no, so are the same, except the manner on how the cylinder extends and how the cylinder retract. Okay, so now for both of the cylinder, no, so using the single solenoid, single acting cylinder. So if we want to maintain the single acting cylinder into an extended position like this one, so either you hold the push button, okay, so or make use, no, so of the relay. So just like on what we've done, no, so from the previous discussion, so we can have the coil of the relay, no. So in European labeling, so the relays, no, so can be found under relays, no, so the coil, so it will have a symbol like this. Okay, so you stop the simulation first. Okay, so drag the coil and then have it connected in parallel. Okay, so with the solenoid valve coil. Okay, so simulate then. Okay, so if you try to observe, so for the parallel connected coils, when one coil is activated, so is the other coil will be activated. Okay, so we name this one, no? So uh, K1, so or basically R1, no? So relay 1. So in American labeling, usually relays are labeled R, but in European labeling, relays are labeled K. So this will be labeled K1, that means relay 1. So we can have the contact, no? So the normally open contact of the uh, relay as a ceiling contact. Okay, so you can find it under general switches, make switch, this one. Okay, so and then since we label the relay as K1, so the contact also will be labeled K1. Okay, so that's K1, and then it will be connected in parallel, no? So like this one. So if we try to do the simulation, so the single acting cylinder extends even if we release the push button because it is being sealed. Okay, so in the same manner, with this circuit, so we can control, no? So assuming that we're using the double acting cylinder, but then using the 5 two-way single coil. So we'll just have it Y2. Okay, so and then simulate. So see the operation of the single acting cylinder can be replicated, no? So that means it can be copied, no? So by or it can be performed by the double acting cylinder using the 5 two-way single coil. Okay, so now this would be the format, no? So of European labeling. Okay, so the the um, direction, no, so of the ladder will be coming from left to right, but for the American uh, standard, so that's from top to bottom. Okay, so during your design process, it will be up to you, no, so on what standard you will be using. So whether it is the European or the US. Okay, so how about the uh, double coil, no? So how do we okay, but before we proceed, okay, so let's try to find, no, so a way wherein we can retract, no, so the cylinder without turning off the supply, no? So just like again, just like what we have done in our previous discussion, we incorporate, no? So we incorporate the use of the normally closed uh, push button. Okay, so the normally closed push button is or can be found under manually operated. Okay, so then click this one, push button, brake. So you insert it in series with the entire circuit. Okay, so you move the positive terminal above. Okay, and then you can label this one an NCPB. No, so that's normally closed push button or basically a stop button. You connect it. Okay, so using so you connect the normally closed, no, push button. As you can see, okay, so okay. So you can see, no? So when we press the normally open push button, the relay activates, Y2 activates. So the cylinder, the double acting cylinder extends, no? So if we want the double acting cylinder to, okay, so to retract, then you just press the normally closed push button. Okay, so the same way with the single acting uh, cylinder, assuming we're using this one, so in the circuit you just need to replace, instead of Y2, so this would be Y1. Okay, so again, if we try to simulate, no, so Y1 is activated, uh, single acting cylinder extends. So breaking the circuit, no, so by pressing the normally closed push button, so will enable the single acting cylinder to retract. Okay, so this is how we create, no, so the ladder circuit using the American, I mean the European, no, so standard, European ladder standard. Okay, so now we are about to control the double acting cylinder using the double coil, okay, solenoid. So okay, so this time we'll try to refresh, no, so the process on how do we create, no, so ladder circuit using the American standard labeling. Okay, so we want the double acting cylinder, no, so to extend and then also to retract. Okay, so for American standard, so everything, no, so can be found under ladder symbols, this one. So you'll just have to have the positive. Okay, so just stop the simulation mode first. Okay, so the positive supply, okay, and then the negative supply, no. So take note. Okay, so if you try to recall, so the process on uh, extending, no, so the process to which the cylinder can extend is by activating Y3, no. So if we try to have the solenoid valve just like this one, okay, so this would be the solenoid valve, no, symbol using the American labeling. So we connect it to the positive and negative terminal and then label this one as Y3. Okay, so you can see if Y3 is activated, okay, when we turn on the supply, so the um, cylinder, no, so the double acting cylinder extends. Okay, so but then again, by practicality, so normally the solenoid coils will not be connected directly to the source. However, they will be uh, or the circuit, no, so will be incorporated with push buttons, no, so that will connect the coils to the source. Okay, so we stop the simulation first, no, and then okay, so we erase this one. We try to incorporate the push button. Okay, so normally open push button. Okay, so this should be let's say start push button. So this would be Y3. So remember in the double acting cylinder, no? So using the single coil. So without the presence of the sealing contact, so the cylinder will retract immediately, no? So once the push button is released, no? So just like with this one, no? So when we try to, okay, assuming we remove the sealing contact of this circuit, okay, and then, okay, so when you try to, no? So let's say we'll be using Y2, okay, so you try to press the normally open push button, so it activates Y2, but when you release, so the cylinder immediately, no, so it immediately retract. Now to prevent that one, that is why we use the sealing contact nose of the relay. Okay, so this one, okay, so to enable the cylinder to remain in extended position, but to, of course, to retract, so you need to press the normally push button. Okay, so okay, for the double acting cylinder, no, so using double coil, so that would be a different case, no? So let's say we try to simulate. So we click the start push button, the cylinder retracts, but if we release the button, as you can see, the cylinder remains, no? So it remains in uh, the extended position, okay? Even if Y3 is de-energized, okay? So recall that in the 5-way double solenoid, no? So the only way for the cylinder to retract is through the activation, no, of the other coil, Y4 in this case. So to make the cylinder retract, no, so we need to have, no, so we need to have uh, another, no, so another um, coil, okay, so which is Y4, no. So Y4, so Y4 is or will be activated when the cylinder, no, so is in extended position, so that when we have another push button, okay, so like this, okay, so shall we say, or let's say this should be labeled as extend, and then this will be labeled retract. Okay, so first we connect the two in series, no, and then the combination will be connected in parallel, no, so with the existing circuit. Okay, so like this one. Okay, so and once we simulate, okay, so to extend the cylinder, you activate Y3. To retract the cylinder, so okay, so you need to activate Y4. Okay, okay, so that's how we operate, no, so the uh, double acting cylinder using double solenoid. Okay, so you activate the solenoid, no, so the coil, no, of the first, uh, or you need to activate the first coil in order for the cylinder to extend, and then activate the second coil in order for the cylinder to retract. Okay, so that extend, retract, and extend, retract. Okay, so that's how the double coil 5-way valve works. Okay, so but take note that the two, no, so the two cylinders cannot, I mean the two coils cannot be run at the same time, no, so because one coil is for the extension and the other is of course for retraction. If you run it at the same time, so the cylinder will be in a position wherein it is being commanded to extend at the same time commanded to retract. So therefore the cylinder will not move. No? So okay. So this is how we um, simulate, no, so the operation, no, of a double acting cylinder and the single acting cylinder. Okay, so the next so the next um, okay, so before we'll continue, by the way, you can increase, no, so I mean you can this is actually the working area by default, so covered with the black line. So you can change, no, so the size by going to drawing size, and then you can change it to A3 or even A2, no, so a much bigger. Okay, so then so you will have the working area as big as this one. Okay, so okay, so the next part will be on the okay, so the let's try to erase this one first. Okay, so the next part is on the process of having the proximity sensor. Okay, now proximity sensors also can be added in the the pneumatic setup using the distance rule, no, so in uh, fluid sim. Okay, so now the purpose of the distance rule is to this one, no, so the purpose of the distance rule is to identify, no, so the position, no, of the sensor. Okay, so let's say we want to add, no, so read switches or limit switches, no, so for the first cylinder, so you just drag the ruler, okay, and then place it, no, so at the top. So since it is a limit switch, then it will be situated, no, so at this end. But if it is a read switch, then it will be right above, no, so the cylinder. Okay, so this one. Okay, so it will automatically place, no, so if you place it here, is assuming you place it here, so it automatically arrange itself, no, so such that the sensor that detects the retracted position will be this one, and then the sensor that will detect, no, so the extended position will be this one if it is a limit switch. But then if it is a read switch, then you just place it above the cylinder, so it automatically positions, no, so that it detects the base, no, so the piston rod. So this signifies as the position, no, so wherein the read switch can detect the retracted position, and then this part here will be the position wherein the read switch will detect the extended position of the cylinder. Okay, so how do we use, no, so the read switch? Okay, so I mean the distance rule, no, so assuming we want to have the limit switch. Okay, so you double click. Okay, so this one, and uh, you label, no, so let's say we use, no, so the symbol a sub 0, a0, so this uh, actually, no, so this actually um, okay, so a0 is the label of the sensor, no, so for the okay, So this detects no, so the sensor for the retracted position of the cylinder, and then A1 no, so A1 is for the what they call this one, the extended no position of the cylinder. Okay, so so before we do it, okay, or before we continue, okay, so let's try to take a look at the parameters no, so of the single acting cylinder. Okay, so you double click no, you just double click the cylinder, and as you can see, so the maximum stroke no, so of the cylinder is 50 mm. That means the length of the rod is, so this one is 50 mm. So meaning to say that from this position, this one, so it travels 50 millimeters, no? So to the farthest end. Okay. So that means in having the limit switch, no, or the proximity sensor, you need to have or to know the maximum stroke, no, of the cylinder, so that you can place the sensor properly. Okay. So 50 mm. Okay, so that would be uh, okay, the length, no, so or the stroke. So just click OK, such that we can identify. So A0, so must begin at 0. Okay, so that means it will be situated at 0 mm. A1 will end, no, so this will end at 50 mm, no, so 0, the beginning position of A0 and A1 will be at 50. So why 50? Because the maximum stroke of the cylinder is 50. Okay, so now the ending position of A0, this one here, so this actually uh, the purpose of the end position is to identify the width, no? So what would be the width of the sensor? So let's say the sensor is 5 mm uh, long, no? So in its width, so you can just type 5. Okay, so assuming that the A1 sensor is still 5 mm, so that means from 50, so the cylinder or the sensor will start with 46, no? So 46 to 50, that's 5 mm. 0 to 5, that's 5 mm. Okay, so that would be a AO and A1, as you can see, no? So the position of the sensor, no? So that's AO and A1. Now if you are still having trouble as to what is 0 to 5 and 46 to 50, so let me show it using this. Okay, so let's say we have the sensor, no? So normally open a sensor, and then it is limit switch, no? So you just type this one A0. So click limit switch, no? Since it is a limit switch, and then you can right click, no? So take a look, just click and then take right click, and then have the component description. Okay, so okay, okay, so perhaps you can have, okay, so right click and okay, so perhaps we can, okay, take a look at the, okay, Okay, so we'll have to, okay, so, okay, so just like in this, okay, illustration, okay, so wherein the limit switch no can be found, okay, so that's, it cannot be, okay, so, okay, we might as well close this one. Okay, so the width, no, so let me explain it. Okay, so the width, no, so of the switch. Okay, so let's say, okay, so the width of the limit switch, no, so the 0 to 5 and the 46 to 50, so it's actually being presented by this one, no? So for example, this would be the starting point. So the distance from this edge to this edge is actually, for example, in that case, that's 5 millimeters. So this would be 0 and then this would be 5. Okay. So the maximum stroke that the cylinder can attain is 50. So meaning to say, if you have this switch, no, this one, positioned at A1, so that means this end here, so will be placed at 50 mm. Otherwise, if it is placed beyond 50 mm, then the cylinder will not be able to reach so this roller. Okay, so this would be situated at 50 mm, but since it is 5 mm in width, then therefore this would be 46 and then this would be 50. Okay, so the same way with the reed switch. No? So if we let this point here to be 0, then if this is 5 mm in length, no? So this would be 0 and then this would be 5, or if it is to be in the A1 position, no? So this would be 50, and since this is 5 mm long, this will be at 46, no? So that's what we meant by 0 to 5 and 46 to 50. But if you opt to have, for example, the width is 3 mm, then you can have it 0 to 3 and let's say 48 to 50, just like that. No? So, okay. So, for the second cylinder, no? So let's say the second cylinder is uh, this one. No? So, assuming this is using a reed switch. No? So, the, what they call this one, the uh, okay. So the double acting cylinder. So we use the distance rule again. Okay, so this one, distance rule. So you just place it here, nasa at the top of the cylinder. So since this is a reed switch, and then double click. So we type B0. So 0 up to, let's say, the same thing, 5 mm, and then B1, and then type 96, and then to 100. So why 100? Okay, so it is because the length of the double acting cylinder by default is 100 mm. Okay, and then we choose the sensor to have a width of um, 5 mm. No? So that's why we have there 0 to, okay, 0 to 5 and then 96 to 100. Okay, so this one, so we'll try to incorporate. Okay, so distance rule. Okay, so just place it above the cylinder and then C0, C1, 0 to 5, and of course 96 to 100. Okay. As you can see, we're using limit switches, reed switches, and limit switches. Let's say we convert this one to limit switches, so just drag it, no, so in this position, and then it automatically uh, adjust itself, no. So okay, so we're using limit switches, reed switches, and of course, no, so limit switches for okay. So now, if you try to take a look at the sensor, no, so let's say this one, the limit switch, no. So let's try to delete it first, and then using the okay American labeling, no. So sensors are normally open switch. So you click make switch, this one, and then take note, no. So it's open, but if we try to type here, so let's say A sub 0. So what happened now is that the limit switch is closed. Okay, so it immediately becomes closed. Whereas if we type this one to be A1, no, so A1, so this is a limit switch. So you can see it is open because, of course, initially it is open. Okay, so but why it is that when we type A0, the switch uh, becomes closed? Okay, so the answer is initially, if you try to take a look at the given, no, so given um, position, no, so of the single acting cylinder, so the single acting cylinder is in retracted position. Okay, that means it is in contact with A sub 0. So that means from normally open, it becomes closed because it is in contact with the cylinder. Okay, so let's say we have A1. Okay, so this would be, for example, type A1. Okay, so limit switch. So A1 is uh, open. Okay, so because it is not in contact with the cylinder. So assuming that we try to simulate, no, so try to take a look at A sub 0. So when the cylinder is moved, okay, if it extends, so as you can see, A sub 0 becomes open, whereas A1 now is closed. Okay, so why is it that A1 is closed? Because it is in contact with the piston rod of the cylinder. Okay, so once the cylinder returns, A1 becomes open and A sub 0 is also closed. No? So the same thing with the reed switches. Okay, so we drag, no, so the normally open. Okay, so stop the simulation first, drag the normally open contact. Okay, so click reed switches, and then this would be B sub 0. Okay, so the reed switch, no, so the contact automatically becomes closed. So the arrow here means that the sensor is being triggered. Okay, so that means it detects, no, so the presence of the magnet, no, so inside. Okay, and then this would be B sub 1. Reed switch, reed contact, no, and then B1. So you can see it's open. So if we try to simulate, so when B1 detects the presence of the magnet, okay, so B1 is closed, okay, whereas B sub 0 is open. Okay, so why it becomes open? Because initially it is actually open, but since it detects no, so the presence of the retracted position of the cylinder, so it becomes closed, but it does not mean that it is initially closed. No, so it is actually initially open, but since it detects that the presence no, of the uh, cylinder no, at the retracted position, that is why it becomes closed. No, so that is how the cylinder. No, so that is how the uh, sensors, no, or the proximity sensors work. No, so in uh, okay in okay, so in the pneumatic circuitry. Okay, so now we'll try to incorporate, no, so we'll try to incorporate the uh, okay, so we'll try to incorporate, no, so the sensor, no, so I mean the sensor in the pneumatic operation, no, operation of a pneumatic circuitry. Okay, so now in this example, okay, in this example, we will be running, no? So we'll be running the cylinder, no? So these cylinders such that when we press, no? So take note of the operation is such that when we press the start push button, so the cylinder will extend, okay? And once the cylinder extends, so it immediately retract, no, so it immediately retract, and then once it retract, no, so that would be the okay, so once it retract, it extends again, and then it retracts again, and then extends again and retract again. So that would be the operation, no, so that we need to create, no, so in this example. So we'll be using the um, double acting cylinder, no? So with single, no? So with single coil. Okay. So this would be uh, okay. So this would be a sequence like a jackhammer, no? So wherein the cylinder retract, extend, retract. Okay. So okay. So we'll be using the okay. So we'll be using the European, no? So perhaps we can make use, no, of the European labeling. Okay, so we can erase this one. Okay, and then translate it later on to American, no? So for European labeling, so we can start with the positive supply, the negative supply, no? So okay. So we want the cylinder to extend. Okay, so that means to extend. Okay, so therefore, okay, so in the relays, no, so can have the valve solenoid. This one, label it Y2. Okay, and okay, so for the cylinder, not to extend this one, so we need to connect, no, so normally open push button in series, no. So let's say start. Okay, we try to simulate, and then if we try to start, so the sequence will look like supposedly with this one. So it extend, retract, extend, retract, and so on. So, but uh, without the proper design, so to accomplish the given task is you need to have manually, no? So start and then uh, release, start and release, and so on, no? So uh, we need to eliminate that portion. So also, if we try to observe when you immediately release, no, so the normally open push button, so there is the tendency that the cylinder, no, so will not be able to reach the farthest um, point it can cover. So uh, we need to make sure that the cylinder will uh, okay uh, be able to reach, no, so the farthest point it can extend, no, so therefore we need to have, or we need to maintain the operation, no, so of the coil Y2, so by having, okay, so by having a sealing contact. So the sealing contact can be provided by the relay, no. So we need to stop the simulation and then have a relay. Okay, so to be connected in parallel. So we label this one K2, K1. Okay, and then also the contact, okay, under manually operated, no, general switches, this one. So sealing contact, okay, so since we're using reed switch, so no, so we're using K1, no, so just uh, put it there, limit switch, no, so just type the label K1 and then you will have it the contact of this relay. So this will be connected in parallel with the normally open push button. Okay, such that when we simulate, if we press start, so the cylinder will be able to extend up to the farthest point. Okay, so the next step is to make the cylinder retract automatically. Okay, so take note. Okay, so recall that for the cylinder to retract, okay, so again take note, no, for the cylinder to retract, then uh, the cylinder or the system must know that the cylinder was already in its fully extended position. Okay, so how do the system knows that the cylinder is in its fully extended position? So it is by the monitoring of the sensor B1. Okay, So this time B1 detects that the cylinder is in fully extended position. So therefore, uh, or thereby the system knows, no, so that the system, I mean the cylinder is in extended position. So we need to create, no, so a normally open contact, and then this would be labeled B1. Okay, so this would be a read contact, no, so and then B1 will be okay. So try to observe what happens to B1, no. So initially it is open, but when the cylinder, no, is in extended position, so B1 will be closed. Okay. So that means that after B1 is being or after B1 has detected that the cylinder is in extended position, so it will command, no. So it must give command to the circuit, no, so that the cylinder will now retract. Okay, so how do the cylinder, or how can the cylinder uh, retract? Okay, so the cylinder can only retract if Y2 will be de-energized. So when you say de-energized, that means it will be uh, cut off, no, so from the supply. Now if you try to take a look now at the system, there is no way, no, for the solenoid to be de-energized by turning off, no, so the supply. But then that won't be the case, because when you turn off the supply, that means you have to restart again, no. So we need something that will be able to de-energize, no, so the circuitry. Okay, so that will make this one turn off. So take note, this can be turned off if there is something, so in between that will be able to cut off the supply, no. So to do that, we may, okay, we may use, no, so the service, no, so of the relay. So take note, only relays have the auxiliary contact. So perhaps we can add a relay, and then we label this one K2, no? So, and then we connect the two in series, okay? And then both of them will be connected across, no, the supply. Okay, so you can see K2. So when we energize, I mean when we simulate, so when the cylinder, no, so extends, B1 is triggered, so activating K2. So after this one, the cylinder must be able to return to its uh, retracted state, no? So it will go back to its retracted state. Okay, so or it must retract, no? So automatically. So to retract, so we need to turn off, no? So this coil. So how do we do that? So we can make use of the contact of the relay, the normally closed contact. Okay, so try to take a look at what happens, no? So this would be a brake switch, and then this would be labeled K2. That means this is normally closed contact. Once K2 is activated, this contact will open. So this will be inserted in between, no? So try to take a look at this one, no? So once this will be inserted in between or in series, no? So it will be connected in series with the entire circuit, or in series with Y2. So such that when, okay, so we try to, let's try to change this one to 5%, okay. So when we try to simulate, so So what happens is that when the cylinder extends, it hits, no? So it hits B1 and then causing K2 to activate, okay? And uh, once K2 activates, it opens, no? So this part here, okay? So now as this contact here opens, so Y2 will be deactivated and of course the cylinder retract. Okay, so for your first few activities, also you will be uh, using also the concept of the um, sensors, no? So or proximity switches. So this will be for the example, no? So uh, in the next example, I'll be showing you so the process, no? So on how can we expand, no? So further the circuit wherein we can automatically extend, no? So the cylinder again after it has been retracted to its uh, initial, no? So initial position.